Alrighty, so in this video we're going to start looking at Algebra 2. We've leveled up finally. This is typically called Algebra 2 because we've gone beyond basic adding like terms and multiplying and that basic stuff, and we're into a higher level of mathematics. Pretty exciting. We're going to start today with just factorising some basic expressions. It's pretty much just going to be the opposite of expanding. So if I had something like 3 outside of x plus 2, what we'd normally say is, well, that's going to be 3 times x, so 3x, and 3 times 2, so 6. Okay? Factorising is saying, what do these things have in common as a factor, as a multiple, that I can pull out the front to write it back in this unexpanded form. It can be really useful when we're doing algebraic fractions down the track. It's also really useful in graphing, which we haven't done much of yet, but you'll see this later down the track. So in this case, again, you can see here, the thing they have in common, 3 goes into both 3 and 6. So I can pull 3 out the front, and then I write the expression divided by 3. So have a look at this example just here. And again, at any point, you might like to stop the video and try something yourself. If you have a printer, you might like to print these notes off and handwrite them. You might like to pause as we go and write stuff down and then have a go at the questions alongside me, or do it on your own. Or you may just like to watch, or maybe if you have a tablet or an iPad or something, you can download the PDF and you can write along as well. Whatever works for you. I'm not going to be too bothered about collecting your notes. I'm not a big note person. As long as you are completing those maths-based tasks and asking me questions when you get stuck, that's all groovy. Okay, so for this first kind of like puzzly example here, I'm going to get you to work kind of in reverse. What I want you to look at is our answer here. And I want you to think, well, what numbers and pronumerals being letters, is going to go into both 12x and 18xy. So the way that I like to think about it, I always start with the biggest number first. So we're looking for the biggest number that goes into both 12 and 18 nicely. Now you might be tempted to pull out 2, for example, because 2 goes into 12 and 18. The problem is it's not the biggest number. So if I was to do that, I would get, it'd be 2, 6, and 9. You can see that there's another number that still goes into both 6 and 9. And so it's not fully simplified. So we're looking for the biggest number that goes into both 12 and 18. That number would be 6. 6 goes into 12 2 times, and it goes into 18 3 times. And I know that I've picked the biggest number because there isn't any number that nicely goes into 2 and 3. Again, we're talking multiplying into them, other than 1. And dividing by 1 is not going to change anything. So that's the number part taken care of. Now we deal with the letters, the pronumerals, the algebra. Okay? So we're looking at, is there a letter or multiple letters that are common between both terms? Hopefully you can see that they both share an x. So just like how we pulled that 6 out the front, I can pull that x out the front as well. And if I do that, it means I'm getting rid of the x, or dividing the x away from both terms, both things. So in the first part, I'm just going to have 2 with no x left over. But in the second term, in the second part, once that x is gone, I'm still left with a y. And that's factorising. That's quite a yucky one. That's all you have to do. So in case finding the factor is a little bit tricky for you, because that's kind of the big idea here, I thought we'd do 3 examples of just finding the highest common factors between 2 terms. When I say terms, I just mean things. Okay, that's like one term, that's another term. Okay, so the highest common factor of 20 and 35. We're saying what's the biggest number that's going to multiply nicely into both 20 and 35. Okay, so I've been talking all day, I've got a bit of hiccups, so if you keep hearing that, I do apologise. Biggest number, hopefully you can spot, is going to be 5. Okay, That's the biggest number that goes into both 20 and 35. Now, if you had a number in mind, like maybe 7, you're like, oh, 7 goes into 35 5 times. And you go, well, does 7 go into 20? And you weren't too sure. Grab your calculator, just hit 20 divided by 7, and you can trial and error it that way if you're ever unsure. Okay, so for B, we're then saying, what's the biggest number that goes into 18 and 24? Biggest number here is going to be 6. Okay, 6 goes into 18 and 24, so I'm going to write 6 here. And then I've got to look, because there's some algebraic terms, some pronumerals, I'm checking, is there any overlap? Are there any letters that are in both A and AB? Again, hopefully it's quite clear that it's A is in both parts, so I can pull A out as well. So if I was going to be fully factorising these, I'd be writing that number out the front and then writing my brackets with whatever was left over. But I'm not worried about that bit right now. Okay, so for C, again, biggest number that goes into 12 and 15 is 3. Okay, now this one's a little bit trickier. Clearly there's x in both parts, but this x squared will throw some people for a loop. What you need to realize is this is like saying 12x, and this is like saying 15xx. So if I divide by an x, or I cancel an x from both parts, I'm still left with an x in that second term. Okay, but I can definitely 100% pull out an x as a common factor. Just note that I can't pull out x squared as a common factor because this isn't an x squared. If they were both x squared, I could make this x squared. Okay, so here are some more examples. Again, you might like to pause this and have a go on your own. We are going to be filling in the blanks. So what number or letter or combination of number and letters goes into these empty spaces to make these equations work. So I'm saying here, 3 times something is going to give me